Okay, so now we look at an example. How can we use the spherical coordinates, okay, in the triple integral? So look at the example question 1. We have to use a spherical coordinate to evaluate the given integral. So the given integral is in terms of x, y, z, which is you have to convert from Cartesian coordinate into spherical coordinate. Okay, so meaning that you have to convert, so you have to make sure that your triple integral will be transformed into the rho, phi and theta terms. So no more x, y and z. Okay, so based on this, okay, we are given the cos of the square root of x squared plus y squared plus z squared dv, and the g is the solid bounded by the z equal to square root of 1 minus x squared minus y squared, and z equal to 0. Okay, so now about the integrand. So you can start with the sketching the solid first, or you want to change the integrand into a spherical expression. So you can do you can start either of them. Okay, so maybe I want to start with the integrand. So I want to convert from the cos of square root of x squared plus y squared plus z squared. So this one in spherical coordinate, it's become, so we know that x squared, y squared, z squared is equal to rho squared. So now it's become cos of rho. So, and then the dv, as we know, the dv is given by rho squared sine phi d rho d phi d theta. So for spherical, we always do this particular expression. Okay. Alright, so now we want to sketch there. So then the triple integral becomes, you have cos of rho square, so this one is part of cos, rho square sine phi d rho d phi d theta. Okay, so for you to determine the limit, then you have to have the solid and the region. Okay, so the solid provided, the information provided give you that the solid is bounded by these two surfaces. So as we know, Z0 is a plane, the floor, right? And what is this? So if you don't remember what is that surface, then you can provide all traces and so on. Okay, or maybe you have no idea if we leave the answer in this form, so we need to modify. So z squared, x squared plus y squared is equal to 1. So it looks like this one is the equation of sphere with this one. Okay, you have a sphere, so meaning that your surface given by this equation is a sphere, but since z is only positive square root, so you have the hemisphere when z is always positive. Okay, so when you draw it, so you have just the hemisphere with radius 1. Okay, and then because we have a solid, and once we see that we have a solid, so meaning that you have a closed surface, where how can you have a closed surface? So as we can see from the instruction, so the solid bounded by the hemisphere, and the z equal to 1. So now we have a solid. Solid must it is a surfaces, and the surfaces is closed. Then we call that as a solid. So that is your solid. So now if that is your solid where you have X, you have Y, and you have Z here. So what kind of solid that you have here? Just like you choose the DV for this, you give a name for that particular solid. So if you have this particular solid and you are standing like this, so what is your region? Where is your region? So your region is a circle lying on the XY. And so you can say that this one is XY solid, right? XY solid. So meaning that your DV should be starting at the DZ and then DA on the XY plane. Okay. So now for the DV, you have to get the limit of Z. So firstly, you want to get the limit of Z. So to get the limit of Z, you have to look at from your solid here. So who is become your base, or who is yeah, okay, about the region. So we leave the region for a while, and then what is your lower bound? This is U, and what is your lower bound? So the lower bound is the floor, which is Z equal to 0. And what is your upper bound? So upper bound is coming from part of the hemisphere. So what is the equation of the hemisphere? So the equation of the hemisphere is given by square root of 1 minus x squared, 1 minus y squared. Okay, now we already obtained the limit of Z. So now about the region. So where is your region? So this is your region. And we know this one is part of the sphere. So of course, your region on XY plane should be a circle. So now we sketch the region, a circle with radius 1. And do you have a complete circle? Yes. So in Cartesian, okay, so the use of the okay, so because now we don't talk about the cylindrical coordinate, because this one also can be solved by cylindrical coordinate, but because of the question here asking for spherical, so we don't bother about the R. Okay, we don't bother about the R, but we do bother about the theta. Okay, so now your region will give you the theta, right? As we know that the theta is angle on the XY plane. Since we have a complete circle, so we know that the theta should be from 0 to 2 pi. Okay, why? Because as you can see here, your region is a circle and you have a complete circle. Because sometimes they will say that the solid is on the first octant. What is the meaning of first octant? Which means that your quadrant should be on the quadrant on 2D should be the X and the Y, they are all positive. So you have to bear in mind about that. Okay, so for that particular question, then you have to provide your theta is 0 to 1 pi over 2 because first octant. So that is the thing that you have to take note. And for this example, because our circle is a complete circle, so we have a 0 to 2 pi. So as we know that what we need to have the theta, so because you can see here there is a d theta, so you can put the limit of theta straight away. So you have 0 to 2 pi. So what else that we need? You have to have the phi and the rho. Okay, so now rho. So to determine the rho, so in this case, okay, so in this case, your rho, what is rho? Rho is the radius of sphere. So as we know that now we have a hemisphere, so the hemisphere, as we know, it is part of the complete sphere with radius 1. So how can you determine the limit of the rho? So just like the R on polar or cylindrical, you draw a straight line starting at the origin and then passing through the surface. So as you can see that the starting point, the initial point is at the origin where your rho is 0. Okay, and then the highest rho is located on this surface. So what kind of surface that we have for these particular points? So we know that that one is the sphere with radius 1. So now we already obtained the limit of rho 0 to 1. So rho is the first one. So you have to put here 0 to 1. So what else that we need to find out? Phi. So what is phi? Phi, as I mentioned before, it is the angle. It is the angle from the z-axis positive. Okay. So since as I mentioned from my previous explanation, this one, so the phi is the angle starting at the z-axis positive. Okay, so you have a cone if your phi is smaller than 45. Sorry, if you have a cone if your phi is smaller than 180. But if your phi is 180, sorry, I repeat, okay, if you will have a cone if your phi is smaller than 90 degree. Remember, the phi is only the size, the angle when you open the umbrella. So when you open it on this size, let's say 30 degree, so this one also 30 degree. Okay, this side, the left side here. Okay, so if you have the phi is smaller than 90 degree, so you will get a cone, concave up. Alright, if you have the phi equal to 90 degree, which means that you have this and you have this, so it is 90. Then you have an hemisphere where your phi is 90 degree. Okay, remember you open it simultaneously on this side and also on this side because this one is a 3D. Okay. Just imagine you open the umbrella. You don't open the umbrella on the left side. When you open it, you will open the whole umbrella and you can use it, right? So similarly for this one, if you open for 90 degree, it's not only this side open. So actually, this one also open 90 degree and this side also open 90 degree and also at the back also open 90 degree. They are the process of the opening of the umbrella is at the same time. Okay. Okay. So now because we have hemisphere, so meaning that your size of phi is 90 degree. So then what we can say that your limit of phi is from 0, why 0? Because the z0 is the stick, the z-axis positive. Okay, so that one is part of the solid. So you open it slowly and the highest phi will be for the 90 degree, which is pi over 2. So now we know that no, sorry, yeah, that's correct. So because pi over 2 is always 90, I'm confused with the pi over 4. Pi over 4 is 45. Okay, so please, for you, don't confuse yourself. All right, so 0 to pi over 2, 90 degree. Okay, so as you can see here, when your solid is exactly part of the sphere centered at the origin with some radius, so all your limit should be constant. Okay, but if you have other solid other than, you have another solid other than spherical, so your limit might be function. Okay, so now let's complete the triple integral. So now we managed to convert the given integral in Cartesian into polar. So let's start to evaluate them. Okay, so cos rho squared sine phi. So here you have cos rho squared. Then you have to integrate the rho first, which means that your sine phi is constant. So you have to integrate the cos. Now you have to integrate the cos rho rho square. D rho. Rho is from 0 to 1. Okay, what kind of technique of integration that applicable here? So it looks like we can use the by parts or tabular method. Okay, so I'm using the tabular. So rho square is a polynomial, cos rho is a trigo. So this one to be differentiate and this one to be integrate. Okay, so I will differentiate till I get 0. So this one become 2p, 2 rho, 2 and 0. Okay, and integrate cos, I will get sine rho negative cos rho and then negative sine rho. And I make a pair and plus minus sign alternately. Okay, and I just copy the answer. So I will get rho square sine rho plus 2 rho cos rho and minus 2 sine rho. So that is the answer. And then so I put the answer here. So rho square sine rho plus 2 rho cos rho minus 2 sine rho. Okay, and then I have d phi d theta. Okay, so then I have to replace the limit of rho is 0 to 1. So when I evaluate that, so I evaluate that here, so 0 to 1. Firstly, I replace the 1, so sine 1 plus 2 cos 1 minus 2 sine 1 minus 0 plus 0 minus 2 sine 0 will give you 0. So then the answer is sine 1 is a value, 2 cos 1 is a value as well, minus 2 sine 1. And when I simplify, I will get 2 cos 1 minus sine 1. Okay, and then I copy the answer over here. So sine 1 minus 2 cos, 2 cos 1 minus sine 1. And now I integrate sine phi d phi d theta. Okay, so you can leave the answer in this form for a while. So 2 cos 1 minus sine 1, and I integrate the sine. I will get negative cos phi, and phi is from 0 to pi over 2, and then d theta. Okay, so 2 cos 1 minus sine 1, and then negative cos pi over 2 minus plus cos 0, and then d theta. So this one is supposed to be okay. So now we have to evaluate cos 0. So what is the graph of cos? So cos 0 will give you 1. Pi over 2, you will get 0. So then you will get 2 cos 1 minus sine 1, and we just multiply by 1, and theta 0 to 2 pi. So 2 cos 1 minus sine 1 2 pi. Okay, so if the question didn't say that you have to leave your answer in 4 decimal places, so you can leave your answer in this form. Okay, but if they said that leave your answer in, let's say, 4 decimal places, then you have to evaluate. Okay, so how can you evaluate cos 1? What is 1 here? Is that you have to set your calculator in radian or in degree? So you have to remember that I mentioned before, all the calculation these are doing in the radian, so you have to set in radian mode. Okay, but you can leave your answer in terms of pi, or you can evaluate the pi. So when you set your radian, calculator in radian mode, so cos 1 will give you this, and sin 1 will give you this. Or you can just substitute, just put this expression into your calculator, and the answer will be 1.5025. If the question asking for leave or give your answer, or give your final answer in 4 decimal places. Otherwise, you can just leave your answer in this form. Okay. But normally, if there is a pi and pi over 2, then you have to calculate. Because the pi and the pi over 2 or just 0, you can evaluate very easily. The acceptable final answer is only if you have 1, you have a number, okay, not pi or not 0. Okay, you have to, for your value here, if it is pi or 0, then you have to evaluate. Okay, but other than that, you can just leave your answer in this form.